As you can see, here is the action potential model. Today, I would like to do an interesting simulation on how action potential moves down an axon. In order to understand the action potential, we have to understand the concept of resting membrane potential first. During the resting potential, the axon is not conducting an impulse. Because of the positive-negative difference between the outside and inside, this resting state is called a resting potential. As you can see, there is higher concentration of sodium ions outside the axon and a higher concentration of potassium ions inside the axon. This is due to the activity of sodium-potassium pump that pumps 3 sodium ions out of the axon and 2 potassium ions into the axon. In addition, the membrane is more permeable to potassium than to sodium. Therefore, the resting axon has a greater negative charge inside and greater positive charge outside, makes the voltmeter records negative 70 mV inside the axon. Next, the process of depolarization begins with a stimulus such as the electrical stimulus that causes the voltage-gathered sodium channel to open. The sodium ion will rush into the axon. As a result, the inside of the axon becomes more positive. And outside more negative. The axon depolarized to membrane potential of positive 35 mV. Action potential are considered an all or nothing event, in that once the threshold potential is reached, the neuron always completely depolarized. Once the depolarization is complete, the cell must now reset its membrane voltage back to the resting potential. To accomplish this, the sodium channel closed and cannot be opened. This begins the axon refractory period, in which it cannot produce another action potential because the sodium channel will not open. At the same time, the voltage-gathered potassium channel opened. Potassium rushed out of the cell, which brings the charge inside the cell back down to where it was, which negative on the inside, positive on the outside. The voltmeter again records negative 70 mV. Actually, diffusion of potassium out of the cell hyperpolarized the cell, in that the membrane potential becomes more negative than the cell normal resting potential. At this point, the sodium channel returns to their resting state, meaning they are ready to open again if the membrane potential exceeds the threshold potential. Thank you.